Okay, welcome back. We are at the second part here, and we're going to do some examples. So let's look at number one, which is looking at the alphabet here, capital letters. And part A says, what are the only capital letters that do not have line symmetry? That do not have line symmetry. So what are the only letters where we can't draw a line that goes through that it could fold onto itself? So for example, in A, if you look at an A, the left side would fold onto the right. If I look at a B, the top would fold onto the bottom. Same thing with a C. Same thing with a D. Same thing with an E. Now an F, though, I can't fold it top to bottom because there's nothing here to fold on, and I can't fold it up and down. So F is not going to work. So F does not have line symmetry. So go ahead and pause this. Go through and see which ones you think are not going to have line symmetry, and then call it back up here and see if you agree with me. All right, now I'm going to go through. G will not work. That doesn't have line symmetry. H is okay. I is okay. J is no good. K is all right. Not L. M is good. N does not work. If I try to draw a vertical line here, that's the temptation, this will fold onto here, but this part has nothing on the right side. It's down here. So N does not work for line symmetry. O is good. P is wrong. Q is wrong. R does not work. S does not have line symmetry. T, U, V, W, all those are vertical. X is vertical and horizontal, and I can rotate it. Y is good. Z is like the S. Z does not have line symmetry. This part doesn't fold to here. This doesn't have that little part coming down. Okay, so those do not have line symmetry. Now, which capital letters have rotational symmetry, and then which capital letters have point symmetry? So rotational means you can turn it, and then point means you can turn it 180 degrees exactly and get the same thing. So as we go through here, rotating, at the beginning here, none of this is working. H, though, if I rotate 180 degrees, the top would rotate down to the bottom. So H actually works for both. I, we can rotate 180 degrees. The top comes to the bottom comes to the top. Nope, 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 nope. The N will have point symmetry. We can rotate that 180. This piece will spin to here, and then this piece will spin to right there. So N has point and rotational. O has rotational and point. O, you can rotate any degree measure, and you'll still have, it'll still look the same. P, Q, R don't work. S has point symmetry, 180 degrees. If I spin this here, the bottom spins to the top spins to the bottom. T, U, V, and W do not have rotational. X does. X has both. And Z has both. So notice that all the ones, if they have point symmetry, then they also have rotational. Okay? So let's flip it on the back. And we have two more examples that we'll do here. Now, number two, you have to read very carefully. It says, between which 2 points is a line of symmetry? There are two solutions. So you have this figure on the coordinate plane. You have a hexagon. Where would you draw a line so that you could fold one side onto the other? Well, you may look at it vertically. You say, okay, I'll take the equation y equals -3. The left side would fold onto the right side. And that is correct. Now what they want, though, is not the equation. They want the points that you can pick to go through. I'll pick 2 points on the hexagon. I'll pick -3, 0, and -3, 4. So between those 2 points is a line of symmetry. Now you may look at that and say, wait a minute, I saw a horizontal line of symmetry where the top folds onto the bottom. And that is correct. Ooh, sorry, I made a mistake here. This is x equals -3, not y equals -3. Vertical line is x equals. Now, horizontal line is y equals. So y equals 2 is the equation. Now, I'll go through this point and this point. That's -6, 2 and 0, 2. Okay, so two answers. X equals -3, the vertical line, and then y equals 2, the horizontal line. All right, and the last one, number 3. Where would you place point E on the coordinate plane to give pentagon ABCDE line symmetry? What's the equation of the line of symmetry? If we draw this, if we connect it, ABCD, now for E is going to be somewhere over here. Now one thing you may look at though, you may look at AB and see that that's not, well, let's see, is that the same as CD? If I pick E over here, I guess the question is, when you look at a pentagon, we typically look at it like this. So you're probably thinking A is that top point. But the problem is, where would I put this to make this AE and ED the same? Now if you look at BA and if you look at CD, they're actually the same distance. Those are going to be the same distance. So I think we're actually going to look at the pentagon starting from up here. If I take this segment 1, 2, 3, 4 and I cut it in half, there's my line of symmetry right there, where the top would fold onto the bottom. Now that line of symmetry would have to go through, okay, looking at it like this. So I can turn this, let's see here. Oh, now I kind of see it. If I pick a point, let's say I pick a point right there, would that work? If I make that point E, that looks pretty good. Now I want to write down, so where would you place a point? So you could place a point right there. Okay, that would be 4, -1. Is there another place I could do this? What if I put the point here? I'll do this in green. What if I do that? Let me turn it again. If I connect that to A and that to D, well, that looks symmetric as well. So it looks like 6, -1 also works. What's going to happen is that any point you choose on this line, at least if you're over this way, is going to have, is going to make this symmetric. So I could even pick 5, -1. I'm not drawing that well. Okay, but as long as that point is on this line of symmetry, then it's going to work. And that is the end of the notes.